everybody. Okay, so in this video, we are just going over some exam questions of hypothesis testing. So hypothesis testing does tend to come up nearly every year. So it's very important that we're very familiar with the skills involved in trying to solve them. So let's look at this one now from 2024. So this was last year's paper. So in 2020, PK Hotels were rated the best hotel chain in Europe by 75% of their customers. In 2024, PK Hotels carried out a survey on a random sample of 1,000 people. Okay, that seems important. Of these, 765 rated PK Hotels as the best chain in Europe. Carry out a hypothesis test at 5% level of significance to see if it shows a change in percentage of their customers who rate PK Hotels the best in Europe. State your null hypothesis, alternate hypothesis, state your conclusion, and give your reason for your conclusion. So my null hypothesis, HO, that would be my population proportion. So now I know I'm dealing with population proportion here because I'm dealing with percentages, okay? I'm dealing with percentages. There's no mention of mean. There's no mention of anything else. I'm dealing with percentages here. All right, so that's my claim here. So my claim is 75%. This is the percentage of customers. See, just write a tiny little line here. The percent of customers who think PK Hotel's the best. Something like that, right? My alternate hypothesis would be this is not equal to 75%. So it would be the percent of people who think PK is the best is not 75%. Right, sorry, my handwriting's a bit shocking there, but sure, look. Right, so let's do my hypothesis. So we're dealing with population proportions, or the only one we can do is our confidence interval. So that is P hat plus or minus 1.96 square root P hat 1 minus P hat all over N. And well, N is equal to 1,000, I believe. Yeah. And then P hat is my sample proportion. Well, 765 out of them 1,000 people voted it. So that is going to be 0.765. So to do my calculations, 0.765 plus or minus 1.96 square root of 0.765 1 minus 0.765 all over 1,000. So if we were to do this out, now it's a 0.675 minus all this, we'll get 0.7387. And then the upper bound, so 0.765 adding all this, will be 0.7913. So this is my 95% confidence interval. So I can say with 95% confidence that my true population proportion is in between these two values. So let's look here. So they're claiming 75%, right? So this 75% is within my, it is in my interval. So therefore, we fail to reject the null. We fail to reject the null, right? So there is insufficient evidence. I'm being a bit bougie here. There's insufficient evidence that the mean or the mean proportion has changed, right? And the reason for your answer, well, that is 0.75 lies within my interval. Right, let's go on to the next one. This is one from the 2023 deferred paper now. So a company produces eye drops. The eye drops are sold in small bottles. The amount of liquid in each bottle follows a normal distribution. Okay. with a mean 10 milliliters and a standard deviation of 0.18 milliliters. Find the percentage of bottles that contain less than 9.857 milliliters of liquid. Give your answer to the nearest percentage. So I see mean, right? So I'm dealing with z-scores. Not dealing with anything, not dealing with any sample means or anything. So what's the probability that a random bottle, X, is less than 9.85 mils? So standardize this, minus the mean divided by the standard deviation. The mean is 10, and the standard deviation is 0.18. I get the probability that Z is less than minus 0.83. So draw a rough sketch. There's 0 minus 0.83. I'm looking for all of this. Well, this will just be equal to 1 minus the probability of it less than the positive, which is equal to 1 minus 0.7967. When you look this up in your log tables, we get here 0.2033, which is roughly 20%. That's my answer there. Let's have a look here. It is known that 55% of bottles contain between 9.85 milliliters and K milliliters of liquid. Find the value of K. So 55%, so probably that 9.85 is greater than X, which is less than K, right? That is equal to 0.55. So I need to standardize it. Minus the mean, divide by the standard deviation. So minus 10, 0.18. So this would be the probability of this is the probability of minus 0.83. And it's less than, I'm just going to call, let's say this is going to be Z in the middle. And then I'm just going to call this like Z1, right? Because I don't know what that Z score is yet. Is equal to 0.55. So sketch it out. Always help to draw a sketch. There is my mean. So this is minus 0.83. This here, we'll say is K, whatever. So the data, or the percentage here is equal to 0.55. Now, information we know from part 1, right? We found 20% of my data lies beneath minus 0.83. So here is equal to 0.2. Therefore, this entire thing, the probability of Z less than K, or Z1, whatever you want to call it, like this Z score, is equal to 55 plus 0.2, 0.75. So now we need to look up the corresponding Z score for 75%, which is equal to 0.675. So my Z score is equal to 0.675. That would be X, or K in this case. K minus 10 over 0.18 is equal to 0.675. K minus 10 is equal to 0.1215. K is equal to 10.1215. That is my answer. There it says correct to 2 decimal places, so K is equal to 10.12 mils. So 55% of my data will be between 9.85 mils and 10.12 mils. Now let's look at a hypothesis test here. The machines used by a company to fill the bottles is serviced and adjusted. The company wants to check the mean amount of liquid in the bottle is still at 10 milliliters. They take a random sample of 50 bottles and find the mean amount to be 9.96. So I see the word random sample. I see mean. So this here is going to be my sample mean, right? And it's still dash. So, and then a random 50 bottles, so n is equal to 50. Now, I still need my standard deviation, but luckily, my standard deviation is up here, 0.18. So 0.18. So, let's state my null. I apologize. Right. So let's state my null. So my null hypothesis would be the mean is still 10 milliliters. My alternate hypothesis would be the mean is not still 10 milliliters. The mean has changed. So I need to conduct a test here. So I'm going to use the test statistic test. Right. So let me calculate my test statistic. So my z test, well, that would be x hat minus the mean, the population mean, over standard deviation over square root n. That would be equal to 9.96 minus 10 all over 0.18 over square root 50. So my z test is equal to minus 1.5713. Now, the absolute value of this, if it's greater than 1.96, we reject. But let's see what it is. So the absolute value of minus 1.573 is 1.5713. That is less than 1.96. Therefore, we fail to reject the null. Right? Fail to reject the null, because if I drew it out here, right, positive 1.96 minus 1.96 minus 1.53, that is around here, right? That is within this region here. That's fine, right? It's just when we get into these little regions here, after 1.96 and before minus 1.96, that's when we have to reject it. Be careful. So the conclusion is the conclusion will be there is not enough evidence to suggest the mean has changed. Right? Reason for your conclusion, we failed to reject the null. As minus 1.5713 is greater than minus 1.96, or you can just repeat then this here. It doesn't follow my rejected reason. Fine. Let's look at this one, 2023. An online word game involves trying to guess a 5-letter word in as few attempts as possible. For this game, each player is given a score S, where S is a real number, based on how many attempts it takes them to guess the word. In Ireland, players' scores are approximately normally distributed with a mean of 3.87 and a standard deviation of 0.36. A player selected random for the players in Ireland. Find the probability this player scored less than 3.5. So, which one are we using? Are we going to be using our sample Z score or our normal Z score? We're going to be using our regular Z score because there's no mention of samples in here. Right? If it said we picked a sample of 50 people, but they didn't. So, we are just going to be using Z is equal to X minus the population all over standard deviation. So, I'm looking for the probability of that scores less than 3.5 minus the mean divided by the standard deviation. So minus the mean is 3.87, and the standard deviation 0.36. We get the probability of Z is less than minus 1.03. Draw a quick sketch. There's 0, minus 1.03. I'm looking for the area beneath it. Here, well, this will just be equal to 1 minus the probability that z is less than positive 1.03. 1 minus then 0.8485 when you look up in your tables, which is equal to 0.1515. Have fun. Right. A random sample of 64 players have a mean score of 3.74. Based on this, a local newspaper claimed Galway players have a different mean score to the players in Ireland. Right? Use the information above, constructing 95% confidence interval of the mean score of all Galway players using standard deviation 0.36 in calculation. So I need to just do a 95% confidence interval. That's going to be x hat plus or minus 1.96 standard deviation over square root n. So a random sample of 64 players from Galway have a mean score of 3.74, and my standard deviation is 0.36. That is 3.74 plus or minus 1.96, 0.36 over square root of 64. This here will give me 3.74 minus 0.0882 and 3.74 plus 0.0882. So this would be 3.6518, and my upper bound would be 3.8282. So, that's it. That's my 95% confidence interval. Carry out now a hypothesis test of 5% level of significance. Test the newspapers claim the Galway players have a different mean score to the players in Ireland. State your null, state your alternate, state your conclusion. So, my null hypothesis is the mean is equal to 3.87. Galway players have the same mean as the players in Ireland, right? The alternate hypothesis is the mean is not equal to 3.87, right? The Galway players score, so the mean Galway score is not the same as players in Ireland. And what's my conclusion? My conclusion would be, well, 3.87 is my claim here. If I go to my 95% confidence interval, that is outside my region, right? So we're going to reject this null because 3.87 lies out my region. So we just say there is sufficient evidence to reject the null hypothesis. Galway scores are different. Right, the reason for your conclusion, 3.87 lies outside my confidence interval. Yeah, my confidence interval. That's it. Right, now it's down here. This is part C. A national newspaper conducts a survey on a random sample of N teenagers in Ireland. 35% of the sample said that they play the online word game every day. Based on this, a 95% confidence interval for percentage P of all players in Ireland who took the game was calculated as accurately as possible. Correct one decimal place, the interval was 26.5% to 43.5%. Work out the value of N, the number of teenagers surveyed. So how do you get this, for example? So that's just p hat minus 1.96 standard deviation over square root n. That will be equal to 26%, which is 0.265. So p hat is going to be equal to 35%. That's what we say here, 0.35. No, sorry, it's not equal to that. No, it's not. Keen viewer, you probably caught on. I mixed it up with the sample mean. We have to use this one. There you go. Right. So p hat times 1 minus p hat. So minus 1.96, 0.35 times 1 minus 0.35, which is 0.65, all over n is equal to, that is equal to 0.265. So bring over to 0.35. That's going to be 0.265 minus 0.35 is minus 0.08. The minus 1.96 equals minus 0.085. Divide both sides by minus 1.96. And I get here square root of the 0.35, 0.65, 0.2275 all over n is equal to this. Square both sides. So 0.04337 squared. So 0.2275 all over n is equal to 0.001881. So 0.2275 divided by 0.001881 is equal to n. That's kind of cross multiplied. Put that in a calculator. We get the 0.2275 divided by 0.001881. Now I'm going to roughly get n approximately equal to 120.94, which is roughly equal to 121. So 121 people in this survey were how many? 121 people were surveyed. Right, so let's look at the 2022 deferred paper now. So over the first season of shows, Mike's scores were approximately normally distributed with a mean of 31.6 and a standard deviation of 3.2. 12 acts were picked at random from the first season, so that's going to be my sample, and the scores were given by Mike were recorded. Work out the probability that the mean of these 12 scores is between 30 and 32. So the mean is between 30 and 32 of these 12. So I need to divide, so subtract the mean, divide by the standard deviation over square root n. That is going to be minus 31.6 over 3.2 divided by the square root of 12. Probability minus 1.73 Z and 0.043. So what's the probability of this? Right, so I'm just check my scores there. So what's the probability of this? So draw out our normal distribution. There's 0 minus 1.73 is over here. 0.043 is over here. Oh, sorry, 0.43. 0.43 is over here. I need to find this area. So again, that's just going to be the probability that Z is less than 0.43 minus the probability is less than minus 1.73, which is just minus 1 minus probability that Z is less than positive 1.73. This will be equal to 0.6664 minus 1 minus score that. Going to be minus 0.0418, which is equal to 0.6246. That's it there. After the second season shows, our website claims that Mike's scores in the second season have changed relative to the first season. So claims, so probably a hypothesis test. A random sample of 20 of Mike's scores from the second season have a mean of 33.5. Calculate the p-value of the sample mean based on a two-tailed test. So this is just going to be 2 times probability that Z is greater than the absolute value of the test statistic. So Z is equal to hash minus the mean over square root n. So the random sample of 20. So, and then the standard deviation now would be the same, I think. So standard deviation of 3.2. 3.2 over square root 20. And then x hat here is 33.5 minus 31.6. Which is equal to right, so it's going to be 33.5 minus 31.6 over 3.2 over the square root of 20, which is roughly equal to 2.66. So I need to find the probability above this now, right? So there's 2.66. I need to find the probability above this. So that's just 1 minus the probability below it. 1 minus this here will be equal to 0.0039. And to get the p-value, times it by 2. That would be 0.00078. So comment on what can be concluded from this p-value in a two-tailed hypothesis test at a 5% level of significance. So since 0.0078 is less than 0.05, we reject the null. We reject the null when p is low, reject that null hypothesis. So as the p-value is less than 5%, this suggests the mean score has changed. Right? So it just means this score is so unlikely to randomly happen. Right? It's so unlikely it's randomly to happen that we just have to reject it. Like, it just doesn't back our claim up. Right? Well, so we have to reject the claim because it just, well, it has to change because in order to get this result, it's so rare that we could get this result. It has to have changed. Like, it had to change. No? Right. Let's look at this one now, 2020. So in a survey on remote learning was carried out on a random sample of 400 students, 135 of the students preferred remote learning over in-person learning. So give all your answers to 4 decimal places. So work out the proportion of the sample that preferred remote learning. So 135 over 400, which is 0.3375. Stunning. Right. Use the margin of error 1 over root n to create a 95% confidence interval for the proportion. That is p hat plus or minus 1 over root n. So n is equal to 400. So it'll be 0.3375 plus or minus just the margin of error. So we're not doing the 1.96 stuff, we're just doing the margin of error. 1 over square root of 400. That would be now 0.2875 and 0.3875. That would be it there. Use the proportion in AI, create a 95% confidence interval for the population proportion that is more accurate than this one. We want to create one that's more accurate than this one. With this one, just use the margin of error, right? The one that's more accurate uses 1.96 times square root p hat 1 minus p hat all over n. So let's do that now. The p hat plus minus that. So 0.3375 plus or minus 1.96. 0.3375, 1 minus 0.3375. All over n, which is 400. So this minus all of this will give me 0.2912. And this plus all of this will give me 0.3838. Right? So I can say with 95% confidence, the true proportion of people who prefer it in online learning is between like 29.12% and 38.38%. Right here, in 2019, people with a prepaid mobile phone spent on average €20.79 on their phone bill each month. Right, on their phone bill each month. In 2021, some students carried out a survey to see if this figure has changed. They surveyed a random sample of 500 people with prepaid mobile phone plans. For this sample, the mean amount spent per month was €22.16, and the standard deviation was €8.12. Carry out a hypothesis test at 5% level of significance to see if there shows a change in the mean monthly spend on mobile phones. State your null, alternate conclusion, and give reason for your conclusion. So, my null hypothesis would be the mean amount spent is €20.79, right? My alternate hypothesis would be my mean amount is not equal to €20.79, right? The mean has changed. So calculations, we're just going to use our z-test, right? Z-test. So in a sample of 500 people, the mean amount spent was 22. So x hat is equal to 22. Standard deviation is 8.12, and the sample size was 500. And the population mean is 20.7. So my test statistic is gonna be 22.15 minus 20.79 all over 8.12 over square root 500. This, when put in the calculator, will give you 3.77. And 3.77 is greater than 1.96. So, conclusion. There is sufficient evidence to reject the null and state the mean amount spent has changed. Reason for your conclusion, z-tests falls into rejection region. Right? Because, as again, here's my thing. Here's positive 1.96 minus 1.96. We kind of want, if the fail to reject, it has to be in here. But since it's 3.77, that is literally past 1.96. So it's in my rejection region. That's why we reject it. Right. Just 3 questions left, really quick. Hopefully. Right, so let's look at this one now from 2015. So a survey of 100 shoppers, that's my sample size there, randomly selected from a large group of Saturday supermarket shoppers, showed that the mean shopping amount spent was €90.45. The standard deviation of the sample was €20.73. So it's X hat plus or minus 1.96, create 95% confidence interval for this amount. Standard deviation over square root n, that would be equal to 90.45 plus or minus 20.73 divided by square root 100. Oh, 1.96. 1.96 times all that. So my lower bound, so 90.45 minus all this, will be equal to 86.37. Then my upper bound, so 90.45 plus all of this, you type in your calculator, you get 94.51. So, part B. Now, a supermarket claimed that the mean amount spent by shoppers on a Saturday is €94 based on a survey. Test supermarkets claim at a 5% level of significance. Right? So, clearly state your null in your alternate hypothesis and your conclusion. So, my null would be the mean is still equal to €94. My alternate hypothesis would be the mean is no longer equal to €94. Right? And I can tell instantly we're going to fail to reject because €94 is within my interval here. 94 is in between here. So we fail to reject the null as €94 lies within my confidence interval. Right? So there's not enough evidence to suggest that the mean shopping has changed. Calculate the p-value and then explain in context of the question. So I need to get my test statistic here. So that is just going to be 90.45 minus €94. My standard deviation was 20.73, I believe. And all over the square root of 100. This will be equal to minus 1.71. So the p-value is just equal to probability that z is greater than the positive version of this times 2. So 1 minus the probability that z is less than 1.71 times 2. That is going to give me 0.0436. Oh, I'm skipping a step here. 1 minus 0.9564 times 2. Put this in your calculator, you get 0.0872. That is my p-value. And then the explanation for it. So if the supermarket's claim was true, right? If the supermarket's claim was true, I'm not going to write this down. So what we say for the explanation here is if the supermarket's claim was true, then our sample results would be right, no, sorry, the explanation would be if the mean amount spent really was €94, then the probability that the sample mean would be €90.45 by chance would be 8.72%. And it is more than our 5%, so therefore we do not reject the null hypothesis. So the chance of this happening is just too great So it actually wasn't down by it wasn't down by like it's not sufficient enough, right? It's not statistically sufficient enough for us to claim. So that is what our p-value is. It's just if our claim was true, the result of getting 90.45 would be around 8.72%, right? Which is greater than our 5%. Right. 2 questions left. The principal of a large school claimed that the average distance from a student's home to the school is 3.5 kilometers. In order to test this claim, a sample of 60 students from the school were randomly selected. The students were asked how far from school they lived. The mean distance from these schools' homes different school to the home is 3.7 kilometers and standard deviation is 0.5. Test the principal's claim at a 5% level of significance. So, my sample mean is 3.7. My standard deviation is 0.5. His claim is 3.5 kilometers. And then the sample size was 60. So his null hypothesis would be the average is 3.5 kilometers. The average distance people are from school. And then the null hypothesis would be the average is not equal to 3.5 kilometers. So the average is not 3.5 kilometers. So, test this claim. We can just use a test statistic if we want. That is 3.7 minus 3.5 over 0.5 over square root 60. This is equal to the 3.7 minus 3.5 divided by 0.5 over square root 60. Get here 3.0. We get 3.1. And then 3.1 is greater than 1.96. It lies within my rejection region. Therefore, we reject the null hypothesis. So the mean is not 3.5 kilometers. So in the above sample, in the above sample of 60 students, 20% of them lived within 2.5 kilometers of school. Find 95% confidence interval for this proportion of students from that school who live within 2.5 kilometers of school. So we want to find the proportion of students. So 20% of them lived within 2.5 kilometers of school. So my p hat is equal to 0.2, right? So that's going to be p hat plus or minus 1.96 times the square root of 0.2 times 1 minus 0.2, which is 0.8, all over the sample size, which is 60. Yeah, here is 0.2. So 0.2 minus all of this is 0.0988. And 0.2 plus all of this is 0.3012. So I can say with 95% confidence, between 9.8% and 30% of students live within 2.5 kilometers of school. Part C, data from 10 years ago showed that at the time, 26% of student population lived within 2.5 kilometers of school. Based on your answer to Part B, is it possible to conclude at a 5% level of significance that the proportion of students living in 2.5 kilometers of schools has changed since that time? So my null hypothesis would be the population proportion is 0.26 or 26%. Then alternate hypothesis would be the population proportion does not equal 0.26. Right? So what do we do here? Well, we know from a 95% confidence interval up here, right? There it is there. Right? 0.26 lies within here. So therefore, as 26% lies within my confidence interval, we fail to reject the null. There is insufficient evidence to suggest it has changed. There is insufficient evidence to suggest it changed. And finally, a statistician wishes to estimate that with 95% confidence, the proportion of students who live within a certain distance of school wishes to be accurate within 10 percentage points of the true population. What is the minimum sample size necessary for the statistician to carry out this analysis? Right, so we don't have any other kind of information here. Really, we don't have a population proportion or anything. So we just need to rely on the margin of error. So we just need to rely on 1 over square root n. We don't have enough information to do anything else. So lies within 10%. So my margin of error is 10%. 1 divided by 0.1 is equal to root n. 10 is equal to root n. Square both sides. 100 is equal to n. So a sample size of 100 would guarantee I'd be right within 10%. And finally, last question here. Thank heavens, my voice is going. A generic drug used to treat a particular condition has a success rate of 51%. A company is developing 2 new drugs, A and B, to treat this condition. They carried out clinical trials on 2 groups of 500 patients suffering from the condition. The results showed that drug A was successful in the case of 296 patients. The company claims that drug A is more successful in treating the condition than the generic drug. Use hypothesis has a 5% level of significance to decide whether there is sufficient evidence to justify the company's claim. Whew. Right. So what is their claim? So they claim to have a success rate of 51%. But in a clinical trial of a group of 500, drug A was successful in 296. So P is equal to 0.51. HA is equal to P does not equal 0.51. So the true population proportion is 51%. So drug A helped 51% of people. The alternate hypothesis would be the percentage of people who were helped by drug A is not equal 51%. So we have to use my confidence interval now because we're dealing with a proportion and percentages, so we can't use our test statistic. So this is p hat plus or minus 1.96 times the square root of 0. Now I need my p hat. What's my p hat? A p hat is equal to, well, 296 out of 500 patients. That is equal to 0.592. So let's just sub this in now. So 0.592 plus or minus 1.96, 0.592 times 1 minus 0.592, all over the square root of n, and my sample size was 500. So my lower end here will be 0.5701, and my upper end will be 0.6139. There is my 95% confidence interval. So 51% does not lie within this interval. So as P equals 51% does not lie in my confidence interval, there is sufficient evidence to suggest that the new drug does not have the same success. as generic. So essentially, just to recap there on that one, right? There was a generic drug, right? The rate of 51%. A company is developing two drugs, A and B. So they carried a clinical trial on test A, right? And you want to see the company claims that drug A is more successful than the generic drug. So if it was more successful, it would be 51%, right? But it's not. It's not because it lies at timing interval, so we have to reject that claim. Right. So let's look at the last part here. So the null hypothesis was accepted for drug B. It estimated the greatest number of patients in the trial that have been successfully treated by drug B. So if it was accepted, right, that means the population proportion of people who are helped by drug B was 0.51, right? And what's the greatest number proportion that could be? Well, we have to use my margin of error, right? So I have to add on my 1 over root 500, right? I can't use anything else because I don't know a sample proportion or anything for, I don't know a sample proportion. So I need to add on my margin of error here to get kind of my maximum possible value I can get, right? So is 0.51 plus 1 over root 500, which is equal to 0.555. So that is like the largest it could be, right? So that means 0.555 out of my 500 patients. So how many patients? 0.555 times 500 is equal to 227.5, which is be equal to 277 patients. That'll be my largest amount of patients there. Right, my voice is gone. This video is mammoth size, so I do apologize. I hope this video some helped you guys, and I'll catch you guys later. Bye.